notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos, section 1. All 33 of those videos have been published already on YouTube. Section 2, all 12 of those have been published on YouTube already. And section 3, all 6 of these have been published on YouTube already in their entirety. So 51 videos from those 3 sections. Please make good use of them. We are now on section 4, measurement. This is the 13th of 17 videos in this section, and I am behind schedule. Next, we will do statistics and try to catch up so that by February 2025, we would have algebra completed. And then March 2025, relations, functions, and graphs. April 2025, geometry and trigonometry. And finally, by May 2025, vectors and matrices. Note this disclaimer down here. This schedule is just a projection which may or may not be fulfilled. And it is not to be interpreted as a contract with anyone. As I said from section 1, all 33 of those videos have been published in their entirety on YouTube. Since this section forms the foundation on which the rest of the syllabus is based, so please make sure you look at all of these 33 videos and know them well. Reminder that you need to know the times tables 2 to 12, since calculators are not allowed in paper 1. So as just stated, all 12 videos from section 2 have been published on YouTube in their entirety. And from section 3, all 6 videos have been published on YouTube in their entirety. We are now at section 4, measurement. At this point here, these videos 1, 4, and 9 have been published in their entirety on YouTube. These others, 2, 3, 5, 6, 7, 8, 10, 11, and 12, only partially published on YouTube. We are now here, objective 11 in section 4, calculate volume of solids, and this is now video 13, and this will only be partially published. 4.11 says calculate volume of solids. Before we go on, recall I said in the introductory video that you will need a good math textbook or a set of 2 to get more practice questions and maybe to clarify something you don't understand in this video. CXC recommends the following. These here. From that list, I would recommend a very good 2-volume set of math textbook that is quite adequate for the current CSEC math exam. Here is a picture of volume 1, Mathematics, a complete course with CXC questions by Raymond Tulsi. And this is a picture of volume 2. Disclaimer, I get no financial or other benefits from the sale of these books. Also, very recently, late 2024, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only. You can navigate by topics or years, where all questions for the past several years have been worked out for you. If you have a question that you need explained, you can ask AI assistant either by text or voice, and most likely that will be explained to you. This is the URL. And on the next slide, I will show a picture of the homepage, RSC homepage, RSC student. As I said, that is the URL. I will include this URL in the description of this video. So all you have to do is click on it and you will be redirected to that site. Here is the home page. You register for it, of course, and subsequent to that, you would sign in. So far, we have completed these 4 objectives from this section. And then these 5 more, which will take us to 9. Also, that 10th one, we have completed that. That was the last video we did. Now we are here, objective 11, calculate the volume of solids. Now note that what you have up here, this up here is the same as down here. So there are some explanatory notes. Volume of prisms, including cube and cuboids, also cylinders, right pyramids, cones, and sphere. Now that's the same thing we had up here, except up here we were dealing with surface area, and now we are dealing with volume. Please note, as I said in the last video, that while this formula here for the surface area of a sphere is not given on the examination formula sheet, it is included in the syllabus, and you would have to learn that, as I pointed out before. Now a similar thing happens here. Volume for a sphere is not on the formula sheet that you will get during the exam. So that means you will have to learn that as well. So this is the formula sheet for exams. Notice this is the top part, and nowhere in this formula sheet do you see V is equal to 4/3 pi r cubed for the volume of a sphere. This is the below of that same sheet, and that's a complete sheet. Again, nowhere do you see volume for a sphere. So it means you would have to learn that. So calculate the volume of solids, prisms, including cylinders, right pyramids, including cones, and sphere. Let us review, first of all, what these solids look like. Now, these are prisms. Essentially, they have 2 end faces, like that one there and that one over there, that are identical, and the faces are joined by rectangles. Cylinder may be considered a special type of prism. It does have an end face here, another one down below there, and is joined by this one face here. If we spread that out, we will get one large rectangle. So those are prisms. Pyramids, on the other hand, they only have one end face, like that, or like this, and the sides are triangles, slanted triangles that join at a point on the top there. The cone can also be considered as a special type of pyramid. And of course, the sphere, which is round like a ball. Now, these are called right pyramids, and the reason for that is that if you draw a perpendicular from that apex and come straight down, it will form a right angle with the base. Same thing with this one over here. Draw perpendicular, it forms a right angle here. Now, volume is the space occupied by the solid. Let us assume that these are all solids. That's a solid block of, say, wood. That's a solid piece of metal. This is a solid piece of, let's say, aluminum, and so on. So we are going to find the volume, the space that these solids occupy. So general principles. For the volume of a prism, or any prism, you find the area of one end and multiply by the perpendicular height. So in this case, if you find the area of this end, we will then multiply by that distance. Same thing for the cylinder. You find the area of one of those two identical faces and multiply by the height separating them. That's for prism. That's a general principle for all prisms. Now for pyramids, you would basically do the same thing you were doing for prisms, except you would take 1/3 of that volume. So it's the area of base times the perpendicular height. Now, if you leave it like that, you will find the volume of prisms. But then if you multiply by 1/3, you find the volume of the corresponding pyramid. And for a sphere, 4/3 pi r cubed. That's about it. So let's consider this cylinder here. If we find the volume of this cylinder on the left here, there is a cone here. Let us say this cone is the same height, and this circle down here is the same as over here. So the volume of this cone will be 1/3 of whatever the volume is of that cylinder. So once you could find the volume of a prism, you can easily find the volume of the related pyramid by multiplying that answer you got over there for the prism by 1/3. So we'll begin with the easiest of these, the sphere. As we said, the sphere is a three-dimensional object that is round in shape like a ball. It was determined a long time ago that the volume of a sphere can be calculated using the formula 4/3 pi r cubed. So let's consider that sphere there. Example 1. Calculate the volume of a sphere if its diameter is 28.0 centimeters. Now get in the habit of recognizing how many significant figures you have there, which would be 3. So volume of sphere is 4/3 pi r cubed. We divide the diameter by 2 and we get the radius. Substitute that in this formula here. Volume is equal to 4/3 pi times r cubed. Enter that in your calculator and you get this answer here. By now you know you cannot leave such an answer for CSEC because it has too many significant figures. They may either tell you where to round off your answer using number of significant figures or decimal places. In the absence of that, we will use the rules we have. This has 3 significant figures. Our answer cannot have more than 3 significant figures. 1, 2, 3. We have to round off at that 4, which is the hundredths position. So we get 11,500, and since we are rounding off at the hundredths position, we take half of that position, half of the 100, which would give us 50 for our uncertainty, our margin of error. And that should suffice for sphere. Any sphere you want to find its volume, that is what you will do. Now, if you find this video useful and interesting, please like and share. That is, like and share. You may also consider subscribing to this channel.